Hello everybody, this video is going to cover our 6.1 notes over polygons. First thing we need to do is define a polygon so that we know what a polygon is and what a polygon is not. So a polygon is a two-dimensional closed shape formed by joining three or more straight line segments that connect end to end at their endpoints. Polygons must be two-dimensional, have only straight sides, and be fully closed without any curves or open gaps. So we do not consider circles to be polygons because they have curves. We would only consider things like triangles, hexagons, things of that nature as a polygon. Okay, so one of the first things that we need to do is know the names of our different polygons that we have. These are going to be really important for us because I need to be able to say, I need you to tell me the interior angle sum of a dodecagon, and you have to know how many sides a dodecagon has. So with that in mind, we're going to start naming the polygons based on the number of sides they have. So first polygon we have, when it's got three sides, that's nice and easy. That's just going to be a triangle. When we have a polygon that has four sides, we actually have quite a few options, right? You've got a square, you've got a rectangle, you've got a trapezoid, you've got a rhombus, you've got a kite, you've got all these things that have four sides. But I need a generalized term for a four-sided polygon, and so we call all four-sided polygons quadrilaterals. I can't promise that I'm spelling these things correctly, but you get the idea. Okay, next, a five-sided polygon is known as a pentagon. Sorry if you hear random noises in the background. I have feral children. Number 6, that's going to be a hexagon. A seven-sided shape will be a septagon. Coming over here to the other side, we've got an eight-sided shape. That's an octagon. I think it's octagon. 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 I don't know. Either an O or an A. I know I should know that, but I don't. All right. A nine-sided shape is a nonagon. I think this is an A. I think all these are A's. 10-sided shape is a decagon. And then notice that we've skipped 11 sides, and when we just go back down to 12 sides, that's going to be a dodecagon. And then anything past 12 sides, we just call it that many sides gone. These will be an n-gon. So for example, an 11-sided shape would be known as an 11-gon. An 18-sided shape would be known as an 18-gon, and so on and so forth. Okay? All right, this next part is how we discover how we can find the sum of all of the interior angles of any polygon that we could be given. Now, what we're going to do is, normally when you do this in class with me, it's a lot more fun. It's not going to be as fun here because I'm just going to kind of like tell you what these things are. But I'll explain as we go through it so that you at least know where all this information is coming from. So what we're going to do is we're going to take each one of these polygons and we are going to pick a vertex. Does not matter which vertex we pick. We're just going to pick a vertex. And then we are going to draw as many diagonals to the other vertices, which are the pointy parts of our shape, that we can possibly draw. I cannot use side links as my diagonals. So for example, in this triangle, I can't connect my top vertice to the bottom left or the bottom right because those are sides. So I can't really do anything there. If you look at a quadrilateral, I can draw a diagonal this way. Okay, that's the only diagonal I can draw. In a pentagon, I can draw a diagonal to this corner and this corner, but I can't draw it to the other corners because those are side links. And then in a hexagon, I can draw diagonals to these points, but I can't draw them anywhere else. Okay. Now, when I draw these diagonals, I'm trying to create triangles within my figures. Well, when you have a triangle, you already just have one triangle that is formed. When you take a quadrilateral and you draw your diagonal, you end up creating two triangles. When you have a five-sided polygon and you draw your diagonals, you end up with three triangles. And then when you have a six-sided polygon, you would end up with 1, 2, 3, 4 triangles that are formed. Now, this is really interesting because when we take our polygons and we break them up into triangles, we actually are going to be able to use the knowledge that triangles have 180 degrees in them to figure out the total number of angles or the total degree of angles that we have inside of each of these polygons, okay? So when you have a triangle, you already know the sum of the interior angles is 180 degrees. You don't really have to do anything. You just know that. Well, in a quadrilateral, you have two triangles. So you can do 2 times 180 to get the fact that quadrilaterals have an interior sum of 360. And then with a 5-sided polygon, a pentagon, you have 3 triangles that are formed. So 3 times 180 will get you 540. And then lastly, a 6-sided polygon, a hexagon, has 4 triangles that are formed. You take those 4 triangles and you multiply that by 180, and you end up with 720 degrees, which is awesome. So essentially, I can take any polygon I want, break it up into triangles, take that number of triangles and multiply it by 180 to get the sum of the interior angles. But like if I have a 32-sided polygon, I don't want to split that up into a bunch of triangles. So we needed to figure out if there is any kind of pattern we can see between the number of sides of the polygon and the number of triangles that are formed. And if you look at each of these, when you have a 3-sided polygon, you have 1 triangle. 4-sided polygon, 2 triangles. 5-sided polygon, 3 triangles. 6-sided polygon, 4 triangles. All of the number of triangles that are within these polygons are 2 less than the number of sides your polygon has. So even though I don't really want to do this, if you have a 24-sided polygon, you automatically know that there's 22 triangles in there. And so you can take that 22 and multiply that by 180 to get the interior angle sum of your 24gon. Okay? So because of that, there is a formula that we can use to find the sum of the interior angles of any polygon. And that's going to be 180 times the number of sides minus 2. As a reminder, this thing right here tells you the number of triangles within your shape. N stands for the number of sides. So you take the number of sides, you subtract 2 from it. That's going to give you the total number of triangles within your shape. And then you're going to multiply that by the interior angle sum of a triangle, which is 180. And that will give you the sum of the interior angles of your polygon. That's interior angles. So now what we're going to do is we're going to look at exterior angles. As a reminder, exterior angles are both going to be adjacent and supplementary to an interior angle. So you've got supplementary and adjacent. And remember that adjacent just means next to. I like to draw this picture for you. Here is an exterior angle and here's an interior angle. So hopefully that you can see here that your interior and your exterior are supplementary. They form a straight line. And then they are both adjacent. They're right next to each other. Okay, that's going to be important for what we're about to do. Now what we're going to do is we're going to talk about the exterior angle sum for polygons. So what we do is we are going to look at each of these shapes. Each of these shapes are known as regular polygons, which means that all of the sides and all of the angles are going to be the same. Okay, so what I would like for us to do is look at this equilateral triangle. We should already know that an equilateral triangle has 60-degree angles at each of its corners. That means that the exterior angles of each of these are going to have to add to your interior angle of 60 to get 180 degrees. So that means that this exterior angle is 120, this one is 120, and this one is 120. If you take each of these exterior angles and you add them together, you get that the exterior sum is going to be 360 degrees. Nice, easy, nothing crazy about that. When we come over here, we have a square. Okay, it doesn't look like a square, but I promise it's a square. Each of the angles in a square are 90 degrees. Remember that these are regular polygons, so all of their angles are going to be the same. That means that each of its exterior angles will also have to be 90 because these things are supposed to add together to get us 180 degrees. When I add each of these angles together, we get an exterior sum of, oh, interesting, 360 degrees again. Let's look over here at our pentagon. I don't necessarily know off the top of my head what the individual angles are of a pentagon. So what I can do is I can use that formula that I just learned, my 180 times n minus 2. So that's 180 times 5 minus 2. And I get that this is 540 degrees for all of the angles on the inside. Well, I have to take that number and divide it by the number of sides because I need each of these angles, and that means that each of these angles are 108 degrees. If each of these angles are 108 degrees, then I know that each of these angles out here are going to be 72 degrees because, again, they have to be supplementary. And then if we go back and we add all of these angles up, all of these 72-degree angles, you will get that the exterior angle sum will still be 360. So it does not actually matter what type of polygon you have. The exterior angle sum will always be 360 degrees. I don't even have to do any kind of work. I just automatically know that the exterior angle sum of all polygons is 360, okay? So 2 pieces of important information. My interior angle sum is 180 times n minus 2, and my exterior angle sum will be 360 degrees all the time. All right, so here are some examples for us. If a polygon has 11 sides, find the interior angle sum and the exterior angle sum. Well, I don't have to do anything with the exterior angle sum because I already know that that's 360 degrees. Now, to find the interior angle sum, I have a formula for that. I have 180 times n minus 2. The n in this case is 11 because it's an 11-sided polygon. And I get that the total interior sum for an 11-sided polygon is 1,620 degrees. Easy peasy. Let's look down here at example number 2. This is a 1, 2, 3, 4. This is a hexagon. So what I need to do first is figure out the total sum of all of the angles inside of a hexagon. That's going to give me 720 degrees. What I'm going to do now is I'm going to add up each of these angles and then subtract that number from 720 to get my missing angle over here. So I've got all angles plus x will equal 720. I don't really want to add all those up on my paper. I have a calculator right next to me. 122 plus 121 plus 117 plus 118 plus 120 gets me 598 plus x equals 720. And then I can do 720 minus 598, 598, and I get that the x will be 122 degrees. And I got that my interior sum was 720. Nice and easy. This is a quadrilateral. I already know that a quadrilateral has an interior sum of 360. It's just one of the ones that I have memorized. So I know that x plus 5x plus 3x plus 3x should give me 360 degrees. That is 5, 6, 7, 8, 9, 10, 11, 12. That is 12x equals 360. So x will equal 30. So x in here will be 30 degrees, and I do have to put a degree sign because one of my angles is x by itself. And that was my dog. All right, let's talk about finding individual angles. So we've already talked about how to find the sum of all of your interior angles and the sum of all of your exterior angles, but we haven't talked individually about those angles that are interior or exterior. That's what we're going to do here, okay? As a reminder, interior and exterior angles together are supplementary. Remember this triangle picture that I drew a second ago? You've got your exterior and your interior, and they're supplementary. And then I just talked about a regular polygon, but a regular polygon is a polygon with all angles and sides that are equal. Okay, so that for us, that's an equilateral triangle, a square, anything that has the same sides and then the same angles. Okay, all right, so we're going to talk about this with regular polygons because that's kind of the easiest way to do this. If a regular polygon has 10 sides, what is the measure of each interior angle and the measure of each exterior angle? So I'm not looking for the sum anymore. Now I'm looking for individual angles. I still am going to start by using my sum formula because I have to know how many total angles I have anyways. So this is 180 times 10 minus 2, and I get 1,440 degrees. So in a 10-sided polygon, all of my angles added together will get me 1,440 degrees. Because this is a regular polygon, I can go back and divide that by the number of sides because that's also the number of angles that are there. And that's going to give me my individual angle. So that means that each individual angle is 144 degrees. Well, that's going to allow me to find my exterior angle because as a reminder, interior angles and exterior angles are supplementary. So I can do 180 minus 144, and I can get that my exterior angle should be 36 degrees. Number 5, same process. I'm going to skip this one just because I want to keep this video short and we still have stuff to talk about. All right, this side over here, finding the number of sides. The easiest way for you to do this is if you have your exterior angle. So I want you to put a note. You need your exterior angle. You need your exterior angle, okay? It says, if each exterior angle of a regular polygon measures 60 degrees, find the measure of each interior angle and the number of sides. Well, finding the measure of each interior angle is easy because we know that an exterior plus an interior should equal 180. This one told me that the exterior is 60. So 60 plus I equals 180. That means that my interior angle would have to be 120 degrees. Now, to find the number of sides, as long as I have my exterior angle, which I do, my exterior angle is 60 degrees, then I can take the exterior sum, which is 360, and then divide it by the exterior angle. And that should give me 6. Okay, we're going to do it again. This one says if each interior angle of a regular polygon, all right, if each interior angle of a regular polygon measures 108 degrees, then I need to find the measure of each exterior angle and then the number of sides. Well, I know my interior is 108. That means my exterior must be 72 degrees, and I need this in order to find the number of sides. So I'm going to do 360 divided by 72. I don't know what that is. 360 divided by 72, and I get that that is 5 sides. Okay. All right, so I put this at the bottom of the notes just to help us kind of like keep tabs on all of the important pieces of information that we need for polygons. Sorry, my brain is not working today. All right, so interior and exterior angles are supplementary. This is always going to be an important formula for you. Interior plus exterior is 180, always. Your interior angle sum can be found by doing 180 times the number of triangles in your shape, which remember is the number of sides minus 2. Your exterior angle sum is 360 no matter what. And then to find the number of sides, remember that you're going to do 360 divided by your exterior angle. And as long as you know those 4 formulas, you really don't need anything else to do polygons, okay? So this is important information down here. And then the other part of this that's really important is that you know the names of your polygons. But other than that, you have enough information to be successful with this content. If you have any other questions, remember that you can go see your teacher during their normally scheduled tutorial times. And I will see you in the next video. Bye.